Okay, so today we're going to talk a little bit about Module 2 homework section 3.2. It's our first assignment in the new module. So it's going to be mostly review, hopefully, for a lot of people. And if not, then you might have a little catching up to do, but let me know. I'm happy to help. What we're going to be doing is using several different techniques for solving quadratic equations. And quadratic equations look like this. You're going to notice the x squared up here. Okay. This is a quadratic equation in what's called descending order. We start with our x squared term first, and then we have an x to the first term here, and then we have a constant term with no x's over here. You don't necessarily have to have all three of these terms, but if you do have all three of them, you want them in this order to be in descending order. This is going to be helpful to us when we solve, because really in all of the different strategies we're going to use for solving, we do want descending order. So that's the first thing to check here is make sure that you are in descending order as you work your way across here. Okay. So the next thing to do then is to solve, we're going to solve this one by factoring. Okay. So if you don't remember factoring, something that you'll maybe want to review, it's not something we'll do a ton of in this class, but I would recommend only factoring when you have this kind of a setup where you have no written coefficient here. That means our coefficient here is a 1 on the x squared. If this is not a 1, or you can at least factor this out to make it a 1, I would not recommend factoring as a strategy for this. There's going to be other methods that are probably a little simpler for that. But this is a good problem to factor because we've got that 1 for our leading coefficient in the front there. Okay. So we have it in descending order. We have that 1 in the front. So I'm going to think about factoring, and there's a lot of different strategies for factoring. I kind of like this one where we set up a little x over here. Okay. And we look at our last coefficient, this -28, and we put it up top here. We take our -3, we put it down below here. Okay. And then we ask ourselves, what are two numbers that multiply to give me this top number and add to give me this bottom number? So I'm thinking about ways I can multiply to get -28. Okay. And I know that if I multiply to get a negative number, one has to be positive, one has to be negative. It's just the only options here if we've got two factors. So I'm thinking about 7 times 4 is 28, right? But I want it to be -28. That means that one of these has to be negative, right? And I know I want them to add to give me a -3. In order to add two numbers, get a negative number, the bigger one has to be negative. So -7 and 4 are going to be the numbers that go into that list. So you're looking for the numbers that multiply to give you this top value, add to give you this bottom value. Really need to think about the signs as we're going through this as well. Okay. And once we've got this done, we're really done. As long as we've got this 1 in the front. More complicated if this is not a 1. That's why we probably wouldn't factor those by hand. But we got that 1 in the front. We can just break this into the two sets of parentheses. We're going to wind up with factoring. Okay. X squared is like x times x. And then we could just take these values and put them in there. X -7 is our first factor. X plus 4 is our second factor. Okay. And then our factoring is done. So our next step then is to take each of these factors separately, set them equal to 0. So x -7 equals 0 will tell us that we move the 7 over to the other side. X has to be 7, right? X plus 4 equals 0. Move this 4 over to the other side, and then we get x is -4. Okay, so this will be a pretty common situation that we get two answers. When you have an equation with a second power up here, okay, that is telling us that there can be up to two answers, not necessarily always two, but there can be up to two answers to these problems. And so not surprising at all that we got a pair of solutions for this problem. Okay, so let's look at a similar problem here. We've got x squared minus 8x plus 12 equals 0. Again, we have descending order, the x squared term first, the x in the middle, the constant term last. Okay. And we have that 1 in the front. So this is another one that it's good to factor on. It's fairly simple, so it's certainly worth factoring. Okay, so I'm going to set up my x just like I did on the first one. I'm going to put the plus 12 up top. I'm going to put the -8 down below. Okay, So what I'm looking for now are two numbers that multiply to give me positive 12 and add to give me negative 8. Okay, well, there's two ways to multiply numbers to get a positive number like this. Positive times a positive or negative times a negative. In this case, because I want them to add to give me a negative number, both of these numbers will definitely be negative. So thinking about my possibilities, 6 times 2 is 12, right? And 6 plus 2 is 8. And then I know those both need to be negative. So negative 6 and negative 2 are going to be my values that go in there. Okay. So that's going to help me with my factoring. I'm going to come over here. I'm going to be breaking this down into two sets of parentheses to make x squared. We always have x times x in the front, and then negative 6 and negative 2. I've really done my work over there. I can just kind of put those directly in there. Again, it's not this simple if this is not a 1 in the front, but if we're going to factor by hand like this, I would recommend doing it only when we have a fairly simple setup like this with the 1 in the front. Okay. So finally, our last step here is to set each of these factors equal to 0. So this is going to give us that x is 6, and then x minus 2 equals 0. It's going to give me that x is 2. And there's my two solutions. Again, not surprising. We have a squared term up here as our largest term. The degree of this expression is 2. And so not surprising that we got two solutions here. Pretty common. Okay, so let's do another similar question here. Now we're asked to find the x-intercepts. So we're not just solving an equation equal to 0. We're finding the x-intercepts here. Sounds quite different. Really isn't different at all. If you remember what an x-intercept is. An x-intercept is the point on our graph where our y is equal to 0. And when we have functions like this, remember f of x is like our y in this case. If I want to find the x-intercepts, what I'm really trying to do here is I'm going to replace my f of x with a 0. And then I could solve this equation. Okay. So in fact, I do have a couple of choices here for how to solve this, and this is one that I could certainly factor. It actually does factor, and it's not that bad. If you remember some of your factoring strategies from a previous course, then you can factor this one by hand. But again, we're mostly going to only factor by hand when these are very simple. And in this case, my x squared is not a 1, it's a 2 instead. So this might be a little more complicated. It's really not that bad if you want to factor it by hand. Nothing wrong with that at all. But I'm going to actually solve this one in the calculator instead. Okay, so if I remember what the x-intercepts are, the x-intercepts are the point where my graph crosses the x-axis. So I can use my graph in my graphing calculator to find these as well. So let's look at that. So what I'm going to do first is I'm going to go into y equals here. And then I'm going to type my equation in here. So 2x squared minus 5x minus 3. Okay, I'm going to set my window, and I'm just going to do a zoom standard here. Probably fine. That give me negative 10 to 10 and negative 10 to 10. Okay, and now the x-intercepts are the point where my graph crosses the x-axis. So there's a x-intercept over there. There's another x-intercept over there again. We're looking at a quadratic equation with this squared here. Can have up to two solutions. So not particularly surprising that we have two solutions there. So if I want to find the solutions to this in the graphing calculator, what I'm going to do next is I'm going to go into second trace, the calc menu here. And I'm going to choose the 0 option. Whenever we are finding x-intercepts, that's the point where our graph crosses the x-axis. Another term for those is a 0 of a graph. So we're finding the zeros here. Okay, and then we're just going to follow the instructions down here. You'll notice our first instruction says left bound. So I'm going to find this one over here, the left point first. So I'm going to go over and make sure that my cursor is somewhere to the left of that, and then hit enter. And then I'll scroll a little bit further past over here to the right somewhere, hit enter again, and then enter again for my guess. And so my first x-intercept is x equals negative 0.5. Okay, or negative 1/2 would be fine as well. Okay, so now I'm going to find the other one exactly the same way. Second trace, choose the 0 option. You want to make sure you're still on the left of that point. So this would be a fine spot to choose. Okay, right bound, we'll just scroll over here somewhere to the right of that point, and then hit enter again for our guess, and that'll give us our Second answer there. And we've got our two solutions. So we do have a couple of options. If you don't remember your factoring at all, you can generally solve these with the calculator in this kind of a strategy. The only trick to that is you've got to be able to set your window, which sometimes takes a little practice. Okay, so we also might give you an equation like this, and we might ask you to solve this with the square root method. Okay, so if we're asking you to solve something with the square root method, what we're going to do first is we're going to isolate our x squared on one side, get that by itself on one side of the equation. So for this one's pretty simple, just going to move the 25 over to the other side, get rid of those. Okay, and then to get rid of this x squared, what we're going to do is we're going to take the square root of both sides. But we can't just do that, because if we just think about this equation originally here, 5 squared is 25. 25 minus 25 would give us 0, right? But negative 5 squared, negative 5 times negative 5 would also give us 25. So 25 minus 25 would still give us 0. So there's actually two solutions to this kind of a problem generally. And, we've seen two solutions for a lot of these problems. And so that's going to be very common. So if you take the square root of both sides of these equations like this, you do need to make sure that you put a plus or minus over here on before you evaluate your square root. And then once you've got that set up, these will cancel. And then over here, we get plus or minus 5. So 5 and negative 5 are going to be solutions to this. So seen it a lot. We got a quadratic equation, degree of 2. We can have up to 2 solutions. It's going to be very common for us to have that happen. Okay. Okay, so let's solve another quadratic equation. This one is not in the standard form that we've been looking at before, because this 2's on the right side here by itself. We don't want that. We want all of our terms in descending order on the left side. So when you don't have standard form, your first step is to get it into standard form. So we just want to move this 2 over to the other side. We get this x squared plus 3x minus 2 equals 0. Okay, on the other side. So the next thing we might do here, if we're just asked to solve this problem, is we might think about factoring. But if we do that, we set up our little x over here, get a negative 2 up top and a 3 down here. And if we're trying to look for two numbers that multiply to give us negative 2 and add to give us 3, it's just not going to happen, because really the only way to multiply two integers and get negative 2 is negative 2 times 1, right? And negative 2 plus 1 is not equal to 3. So this one can't be factored. It just is not going to work. Okay, so in that situation, if we're going to solve this by hand, really the option that we're going to take is to solve this with the quadratic formula. Okay, so quadratic formula looks like this. Minus b plus or minus big square root with b squared minus 4ac all over 2a down at the bottom. Okay. And, our a is going to be this 1 up here. Our b is going to be this 3. And then our c is going to be negative 2. And then we'll just plug this in and work it out. So the opposite of b is negative 3. So this is 3 squared minus 4 times a is 1 times c is negative 2. All over 2 times a. This might be a problem that you would be tempted possibly to put this into the calculator and find the zeros on. Not going to work particularly well in this place. The instructions specifically ask you for the solutions to this using radicals, and what you'd get from the calculator are decimal approximations. They wouldn't be the exact values. So for the question that we're asked here, we really have to do this by hand. We really have to use the quadratic formula. Again, if you don't remember the quadratic formula at all, let me know and we can work on this. So I would just throw this whole radicand, everything that's inside the radical into my calculator. This is just 9 plus 8 or 17 here. Okay, and then we've seen that we've gotten 2 answers on many of these problems. We have 2 answers here again because of this plus or minus here. -3 plus the square root of 17 is our first, divided by 2 is our first solution. -3 minus the square root of 17 divided by 2 is our second solution. Okay, so if you try to factor it and it's not working, it just that'll happen sometimes. Then if we're doing it by hand, our next option here is the quadratic formula. Okay, so let's look at one more quadratic equation. This one, we've got several decimal points in all of the numbers here. This is a model that gives the sales of a company in billions of dollars, X years after 2000. Okay, so the first thing that we want to do here is, this is a problem that it's not practical to do very much with by hand. And in fact, we're just asked to graph the function and then answer some questions about the graph. So to me, this is just a 100% a technology question. We're just going to start by going into y equals here, clearing out whatever you've got in here, and we're going to type our function in. So -1.649 for me here, x squared plus 37.629 x plus 383.520. Okay. And then I'm going to use the information from this problem here to help me set the window. So it says X years after 2000. It's 2021 right now. So I'm just going to set the window from 0 to 21 here for my X min and X max. And then I'm just going to choose zoom fit. I'm sorry. Zoom fit so that the calculator will choose Y's that are appropriate with the X values that I gave it. Okay, and that should give me a good picture for what's going on. In some of your questions in MyMathLab, you'll have some multiple choices, and then you'll just want to set the window based on those. But if you don't have that information, like we don't in this particular problem, use what you know. I mean, this is the years after 2000, so 0 to 21 should be fine. That takes us from 2000 to the present. Okay, and so there's our graph. So next, when will the sales be $530 billion? Again, if I wanted to, S of X is my sales. I could put the 530 in here. I could solve. I could use the quadratic formula, but with all these decimal places, it's not really necessary to do that. It's much more practical, in my opinion, to just use the technology that we've got to do this. So what I'm going to do is I'm going to go into y equals. I'm going to go down to y2. I'm just going to draw a line across that $530 billion mark. Okay, and then I'm going to graph. And then you'll notice there are going to be 2 solutions. We've seen that a lot. Anytime we have a quadratic equation, doesn't have to give you 2 solutions, can give you 1, can give you none sometimes. But the most common situation is you'll have 2 solutions to questions like this. And so we can find those. Calculators very good at this. If we just go into second trace, we're just looking for where these 2 graphs intersect. So we'll choose option 5 here. Okay, you'll notice it asks me for the first curve here. I've got Y1 selected, so that's fine. Second curve, it's got that Y2 selected. Okay, so last, I just want to guess. I'm going to find this left point over here. So I just want to get somewhere to that ballpark, and that'll give me the answer that we're looking for there. Okay, the instructions in this problem ask me to round up to the nearest year. So for this one, I would just say that 5 years. Okay, after 2000, which no one would ever say, really a better answer here is in 2005 is what we're looking at there for the first one. Okay, and then we can do the same kind of thing for the second one. Second trace, choose intersect, number 5 here. Really, you could just hit enter and then enter for our first 2. And then we need to get closer to that second point. Okay, and then it'll tell me where this is. Again, if we're rounding up to the nearest year, like the instructions say, that this would be in 2018. Okay. And so there's our 2 years where this would happen. So again, problems like this, especially with all the decimal points, kind of a dead giveaway that this is a technology-based problem. And so our calculator can handle that quite nicely. Okay, so hopefully that's enough to get you off to a good start in this first homework assignment for Module 2. Please let me know if you have any questions.